Binomial theorem for fractional or negative integer index. See, 1 plus x to the power of n, when n is positive integer, we always write in this. When we expand, we get this. Now, if I replace n with minus n and x with minus of x, the same transformation if I do in this expression, so I will get this. Now, you can see that this minus and this minus will club, will give you plus, and all these one minus from a, one minus from a, one, and this is already positive because square is this. These two minus can be clubbed to get positive here. Here, this is a minus, this is a minus, this is also a minus. So 4 minus will give you a plus. So you can see this is what we'll get. The only thing in this case is this expansion goes till infinity. Now, we can write 1 as nc0, we can write n as nc1, we can write this as n plus 1 c2, we can write this as n plus 2 c3. Seeing this, what we understand here, if let's say we have to see the coefficient of x square. So if you have 2 here, here it is n plus 1, 2 is as it is. If we have to see the coefficient of x cube, we have n plus 2 and 3 is as it is. Therefore, coefficient of x to the power of r in 1 minus x to the power of minus of n can be written as n plus r minus 1 cr, where n is integer. Okay, so now let's apply this to solve a question of J. The question is the coefficient of t to the power 4 in the expansion of 1 minus t to the power 6 upon 1 minus t the whole cube. We are given 4 options here. Let's see how we solve this question. This can be written like this. Now, we can expand this using the normal binomial because this index is positive. In place of x, we will write here minus t to the power 6 and we will expand, we will get this. And this we will write as it is. Now, in the question, you are asked to calculate the coefficient of t to the power 4. Now, you know that when you expand this, you will get coefficient of increasing power, increasing and integral powers of what you call t. You will never get a fractional power of t when you expand this. So, 6, 12, 18, these powers of t will never give you t to the power 4. So, these all are waste term for you. The only term that is available here is 1. 1 multiplied with this. So, the question was t to the power 4 in the given expression, but that reduces to what? T to the power 4 in this expression. Now, for this, we can apply the formula what we have discussed. So, n is 3 here, r is 4. So, formula is n plus r minus 1 cr. 3 plus 4 minus 1 cr. We apply this, we will get 6c4, which is same as 6c2. When we solve, we get 15 as the answer for the question.